Okay, so for today's video, what I wanted to do is teach you guys how to figure out the torque of a fluid line, a rigid fluid line. To do that, there's a chart in AC 43131B is where I'm at. Again, you guys have access to this book. It is a free download, but I also, on most of the equations, will go ahead and put this chart for you so you don't even have to have the book. But it's in table 9-2 of chapter 9 of AC 4313. And what if you look at the top, it says the wrench torque tightening for AN 818 nut. What that is that's called a B nut. So that's the torque for a B nut. On this side right here is a dash number tube, or it also gives you the tubing outside diameter. So you really only need one of those columns, but it's nice to have both of them. Like for instance, we know that a dash 6 tube is 6/16, but it's also a 3/8, right? So a dash tube is 3/8. So that means the same thing. A dash 10 is 10/16, which is also 5/8. Sorry, some of that came off the screen there. A dash 5 tube would be 5/16. So pretty simple to read. That's either the dash number, the tubing outside diameter. This column is for if the tube and the B nut and all the parts to the line getting torque are made out of aluminum, which is pretty common. Then you're going to use this minimum maximum. If all the parts of the torque, whatever you're torquing together, is all made out of steel, then you'll use this column here. Now, if it's ever intermixed, let's say you have an aluminum fitting on a steel line, you always go with the softer material, so it's always going to be aluminum. So for instance, if you had an aluminum B nut, like a blue B nut, and it's going on to a union that's black in color, that means it's steel. Well, you have a blue and a black, you're going to go with the aluminum. So always go with the softer metal if it's intermixed. Typically it's not going to be, it's going to be all aluminum or all steel. And then over here is just some specialty stuff here. And then I'm going to teach you in another video this last column here, but I want to concentrate on one thing at a time so you don't get overwhelmed here. All right, so we're going to do 3 practice problems on this. Try and figure out the torque of a given line. So I'm going to come down here to my my practice equations, which is very similar to what you'll see on a worksheet or a test. It says, what is the torque range for an aluminum B nut used on an AN 5052 composition? And there's my outside diameter, 0.375, and my wall thickness is 0.049. Really, all I need to know out of all these facts is what is the outside diameter and what's it built out of. So in this case, it's built out of aluminum, so we're going to use the aluminum column, and it's 0.375. Now it makes it a little tricky because we have to know, okay, well, how many 16ths is 0.375? So to do that, we would have to kind of go through these and figure out which one it is. But I know through experience that it's going to be the 3/8. So basically this line, the AN 5052, the one I just talked about, 0.375 by 0.049, it would be torqued to, it's the 3/8, the dash 6, it would be torqued between 110 and 130. And it has a range, so that's minimum, that's maximum. Anywhere in that range would be acceptable. All right, so let's try another one. Let's try the next one on my list. The torque required to properly tighten an an aluminum fluid line with the B nut with the part number AN 818-8D. Now this one's a little trickier because it's just giving us the part number of the B nut. Well, if we look up here, it's AN 818 nut, so we know we're going to be using this chart. So what do we need to know? We need to know outside diameter of the tube. Well, if you remember me talking about this in a previous video, the AN 818 tells us what type of fitting it is, and that's a B nut. The 8 tells us the size of the tube it goes on, and the D means it's made out of aluminum. It would be blue color. So 8 would be 8/16, so this would be a 1/2 inch. It would go on a 1/2 inch line. And it is aluminum, so we're going to use the aluminum column. So I come over here to my chart. I find the 1/2 inch. It's also a dash 8 tube. So we really could have just used the dash 8. We didn't have to know it was a 1/2 inch. And the torque range would be from 230 to 260. And again, this whole chart is in inch pounds, so it's all in inch pounds. If you needed the torque in foot pounds, you could always convert. All right, and then finally, the last equation we'll try here. The torque required to properly tighten a steel fluid line with a B nut with a part number AN 816-6, okay? Well, now this time we're using a steel line. It says right here, it's a steel fluid line, and we also have a steel fitting, and how we can tell that is there's no D. It just has AN 818-6. So the AN 818 is the B nut. The 6 is on a 3/8 line. And because of these not there, this would be a black fitting, it would be steel. So they're both steel. So this time we're going to use the -6 column, but we're going to go over to the steel. So -6 column, we're going to skip aluminum, come over here to steel, and it's 270 to 300 inch-pounds would be the answer to that equation. So hopefully you guys know how to use this chart a little bit. It's a lot nicer than trying to do the the torque calculations on a fastener, like a screw or a bolt, because this one you really only need to know two things. You need to know outside diameter and you need to know composition. Once you know those things, bam, you have your torque. And I'll give you guys a little shortcut when you're trying to figure out the outside diameter of the tube. If rather than trying to measure it with a micrometer or a caliper or a ruler or anything like that, it's really easy. If you have a wrench set, let's say you have a wrench set and you have the 5/16 wrench handy, just take that 5/16 wrench and try and put it on the outside of the tube, and if it fits snugly, now you have a 5/16. So a little trick I had learned that makes it a little shortcut to trying to figure out torque. So again, all you need to know is the outside diameter of the tube and its composition. If you're ever intermixing composition, meaning you have an aluminum and a steel part on the same torque, then you are going to go with the aluminum. Some other things I wanted to mention, this is going to be a test question. One of the most common mistakes made with tightening down of the B-nuts is over torquing. So a way to prevent that is always use this torque chart and you won't have a problem. So just remember that that is a common mistake because everybody wants to keep tightening it more and more, and what ends up happening is you'll crack the flare, or you'll crack the B-nut or the line or something, or twist the line, and it's going to cause a lot of problems. So the way to prevent that is always just use the torque in either the maintenance manual that you're working off of, task card you're working off of, or if it's not mentioned in either one of those documents, then you can always revert to AC 4313 1B. Also, another thing is obviously you're going to be using a torque wrench because it's a torque specification, but it's one of the tools you are going to probably need to torque a B-nut is something called a crow's foot we talked about in the last unit, because you can't torque with an open end wrench or what we call a combination wrench because there's no way to calibrate that. But basically what a crow's foot is it's the open end side of the wrench, and you put it onto the torque wrench, and that's a way you can torque a fluid line. Just remember also, if you ever do use a crow's foot, make sure that you always hold the torque wrench 90 degrees to the B-nut. Otherwise, you're going to have to do a torque calculation if you hold it straight. So that's some stuff we talked about in the previous unit. All right, we got one last video in this section. It's going to be about the, it's going to be on the same chart. It's going to be about bend radius, but I'm going to do that in a separate video. So again, you guys, hopefully you're watching these videos, learning this stuff, because you will be tested over it shortly. But if you have any questions, feel free to reach out to me. Thank you.